Every single day, a massive percentage of global internet traffic never reaches its destination. Instead, it hits a hard, impenetrable wall. You have likely encountered this interface yourself. Just a moment, performing security verification. While the UI suggests a slow connection, the browser is currently being held in a staging area. This restriction limits the scale of automated attacks, botnets attempting to scrape data, spam forms, or saturate the server's bandwidth. By treating this specific screen as a diagnostic log, we can reverse engineer the programmatic logic executing behind those few lines of text. This diagram shows the underlying architecture. A user connects first to a protective outer ring rather than the central core. This core is the origin server, the physical machine hosting the website. The outer ring is the edge network, a distributed security layer. When staring at the "just a moment" prompt, you are physically halted at the edge network. Your browser hasn't touched the actual website yet. The challenge is computational triage. In roughly 3 seconds, the edge must mathematically distinguish a legitimate browser from a headless, malicious script. This screen is an active computational filter, forcing an automated negotiation to protect web infrastructure from malicious scaling. The process begins the millisecond you type a domain into your URL bar and hit enter. As this animation shows, your request does not travel to the destination. It is abruptly halted at the closest geographic edge node. By intercepting the connection here, the true IP address and physical location of the origin server remain hidden. You cannot attack a target you cannot find. We can confirm this interception by looking at the bottom of the screen. Look at the string labeled Ray ID. The exact moment the edge intercepts your request, it generates a unique cryptographic trace identifier and tags it to your session. That specific alphanumeric code tracks the complete lifecycle of your single request as it is analyzed across a massive, decentralized global network. As long as the interstitial text is visible on your monitor, your request remains paused. The edge network requires this pause to configure a sandbox environment and prepare a specific test for your machine. Older security models forced traffic to a separate domain or required users to decipher blurry text. This pause happens inline, operating silently in the background. The Ray ID provides literal proof that your connection has been successfully hijacked and held for inspection before any actual website data is exposed. The mechanism for that inspection is written right into the instructions. Enable JavaScript to continue. The edge server actively sends a hidden JavaScript payload down to your client. This initiates a defense strategy based on asymmetric computational burden.
The test is cheap for the server to issue, but expensive for the client to pass. This diagram contrasts the two actors, a standard human browser on the left and a lightweight bot script optimized for speed and volume on the right. The payload forces the machine to execute a mathematical proof of work alongside a check of its browser environment. Executing JavaScript natively requires a full rendering engine. Botnets avoid rendering engines because they consume massive amounts of CPU and memory, ruining their ability to scale an attack. While you spend 3 seconds reading the screen, your local hardware is silently churning through complex math in the background. If the requester is a simple, headless bot, it lacks the execution environment. The math goes unsolved, the process immediately fails, and the edge silently drops the connection. All of this high-intensity computation happens locally on your hardware. The server delegates the heavy lifting to the visitor. This text is a literal command, forcing your hardware to cryptographically prove it possesses the heavy resource footprint of a human. That brings us to the second half of the instruction text, and cookies to continue. Once your browser successfully finishes computing the background JavaScript challenge, the hard part is over. The browser transmits the solved proof back to the edge node for verification. The edge node verifies the math, updating your status to verified. The server then issues a specific token back to your browser, a clearance cookie. This cookie guarantees state persistence. It acts as a durable digital passport. Because you hold this token, your machine won't have to resolve the heavy math problem on every subsequent page click. The interface confirms this exchange. Verification successful. Waiting for www.make.com to respond.
At this exact millisecond, with the verification successfully completed and the token issued, the edge node finally lifts the restrictive routing barrier. The edge securely proxies your original request inward. It finally travels straight into the central origin server to retrieve the actual web page data. The cookie transforms a momentary proof of work into a durable credential, granting secure, uninterrupted passage to the destination. Here is the entire verification pipeline mapped out from end to end. Step 1. The initial HTTP request triggers an immediate edge intercept. Step 2. The network generates a unique Ray ID to track the session lifecycle. Step 3. The edge forces the invisible execution of the JavaScript proof of work challenge. Step 4. The server verifies the math and issues the clearance cookie. Step 5. The routing restriction is lifted and the request is successfully forwarded to the internal server. This entire 5-step, cryptographically secure negotiation happens flawlessly in the 3 to 5 seconds you spend staring at the text. There is no manual friction. You avoid pausing to identify photos of traffic lights or crosswalks. This process repeats millions of times every second, scrubbing the inbound traffic of a significant portion of the web. The Just a Moment screen facilitates a silent, high-speed authentication, verifying identity through computational cost before the first byte of data is ever sent.